Hi, my name's Amber Cole Glazier. In the next few minutes, I hope to impart a little bit of the knowledge that I've gained this semester in astronomy. We've studied everything from the Copernicus theory to cosmic distance ladders and Hubble's constant. We even studied several scientists and astronomers along the way, but my favorite section was that over the binary star systems. For those of you who have watched the original Star Wars like I have, you'd already seen a set of binary stars, though most of us didn't realize. Luke Skywalker's home planet, Tutani, had two suns. Well, these two suns are what a binary star system is. That's two stars that are orbiting the same center mass. And there's several different ways that these types of stars can be detected. Those that can be seen visually or through the use of a telescope are called visual binaries. Another way of detecting them is by detecting when the dimmer star passes in front of the brighter star, causing a momentary eclipse. These are considered eclipsing binaries. Another type is spectroscopic binaries, where scientists must measure the wavelengths of the light being emitted from the stars to base the nature of the binaries. Another type is astrometric stars. That's where one star seems to dance around empty space. Their other companion star is actually inferred rather than seen. Binary stars were originally discovered in 1617 by Galileo when he was asked to turn his telescope to the second star on the Big Dipper's handle. He stated one star seemed to be two. Well, these two stars actually turned out to be six. The phrase binary system, however, wasn't coined until 1802 by Sir William Herschel. There's a few other ways you can classify binary stars. Either a close binary system or a wide binary system. Close binary systems are those that evolve nearby each other, and they are able to pass mass between one star to the other, ultimately changing the composition of the two stars. Wide binaries, however, have an orbit that keeps them spread wide apart and have very little to do with the other's evolution. Binary stars form just like any other star. They start from a cloud of spinning dust and gas, whose gravitational attraction causes them to collapse on themselves, creating a dense hot core. As the star is created, if it fractions off, this causes two stars to be born into a close binary system. If it remains to be just one, then it'll be part of a wide binary system. The star spends the majority of its life on the main sequence. This is where most stars spend their life, during their hydrogen fusion era. This is where they're converting hydrogen into helium. Once the supply of hydrogen is gone, however, the star will slowly move off of the main sequence towards the end of its life. When a close binary star system has one star that dies and turns into a white dwarf, that white dwarf, being so close to the partner, can actually continue to steal mass. They will continue to steal the hydrogen, causing fusion to begin again, and when this releases huge amounts of energy, it's extremely luminous again. And white dwarfs are capable of doing this over and over. As the hydrogen is burned off, it causes a nova. Well, these novas continue to happen as the white dwarf moves along the line. Each time, a little bit of hydrogen lasts and burns off with the next one. Eventually, this causes a supernova once the mass reaches that of 1.4 solar masses. When this happens, ultimately the star becomes a carbon fusion bomb and is completely destroyed. I hope that with the information I've given you, you've learned a little bit extra about binary stars. For those that are still interested, our class in astronomy actually used NASA's website to do very exciting simulations. You can actually Google the word eclipsing binaries and then go to NASA's website and use the simulation to create different orbit patterns and see what happens when one star is brighter than the other and what the inclinations can be. I hope that everybody will take the time and actually go and watch and play with the simulation. It was very educational. Thank you.